Okay, well, we'll go ahead and get started. Hello and welcome to NOAA's National Ocean Service Science Seminar Series. My name is Tracy Gill and I'm the coordinator for this series. We have partnered with the U.S. Global Change Research Program, or USGCRP, on a special seminar series on the 4th National Climate Assessment. My co-host on this series is Katie Reeves, Engagement and Communications Lead for the USGCRP National Coordination Office. I will provide a few seminar logistics, and then Katie will introduce the seminar and speakers. Here are the logistics. There are two presenters, so we will allow a few questions after the first talk, as long as we can start the second talk at 1:30 to give time for the second presentation. Then we can allow additional questions for both speakers after the second talk. Please type all questions into the chat box. If you are interested in getting a PDF copy or recording of today's presentation, Katie will list the relevant websites in the chat box where they will be posted in a few days. Or you can contact me, tracy.gill@noaa.gov, or Katie Reeves, and our emails are in the chat box. If you are not on NOAA's weekly science seminar list, but you'd like to be, please email me at tracy.gill@noaa.gov and I will add you to this list. Folks in the room, please sign in and silence your phones. And now Katie Reeves will introduce our seminar and speakers. Katie?
Great, thanks. Thank you, Tracy, and thank you to NOAA for hosting what is the 10th and penultimate installment of our 11-part webinar series. That's very exciting. That's been focused on the findings of the 4th National Climate Assessment. I'm Katie Reeves, the Engagement and Communications Lead for the U.S. Global Change Research Program, or USGCRP. For a little bit of background, the Global Change Research Act of 1990 mandates that USGCRP assist the nation and the world to understand, assess, predict, and respond to human-induced and natural processes of global change. And one way that we do that is through the development of a quadrennial national climate assessment. The 4th assessment was released in 2 volumes. The first volume, the Climate Science Special Report, was released in November of 2017, and that was covered in an earlier webinar series, which can be found on our website, and I've shared that link already. The second volume, Impacts, Risks, and Adaptation in the United States, is the focus of this series. And as that title indicates, NCA4 Volume 2 assesses the observed and projected impacts of climate change across the U.S., covering 17 national level topics and 10 regions. The assessment was released in November of 2018, and you can read and download it at nca2018.globalchange.gov, and I shared that link a little earlier. Today, I'm very pleased to welcome Dr. Meredith Muth and Dr. Clarke as they present on international effects and complex systems in a changing climate, findings from the 4th National Climate Assessment. Dr. Muth currently serves as the Regional Drought Information Coordinator with the U.S. National Integrated Drought Information System, or NIDIS, program, where she is working to improve the nation's capacity to manage drought-related risks. Prior to joining NIDIS, she worked for 10 years as an international program manager in NOAA's Climate Program Office. Her responsibilities included leading several international partnerships and activities related to the development of climate information for decision-making, with a strong emphasis on partnership development, coordination, and policy. Dr. Muth was the federal coordinating lead author for NCA4 Chapter 16, Climate Effects on U.S. International Interests. And today's second presenter is Dr. Clarke. Dr. Clarke is an expert in energy and environmental issues with a focus on climate change mitigation strategies, energy technology options, and integrated multi-sector modeling. He's currently the research director at the Center for Global Sustainability and a research professor in the School of Public Policy at the University of Maryland. Prior to this role, Dr. Clarke led the Integrated Human Earth System Science Group and directed a range of integrated assessment modeling activities at the Joint Global Change Research Institute. He has served as an author and coordinating lead author for the Intergovernmental Panel on Climate Change, the National Climate Assessment, and the National Research Council, and he's also led a number of multi-institution studies on climate response options. Dr. Clarke was the chapter lead author for NCA4 Chapter 17, Sector Interactions, Multiple Stressors, and Complex Systems. Thank you both for joining us for today's NOAA Science Seminar, and I'll turn it over to you, Dr. Muth.
Thank you, Tracy and Katie, for organizing this webinar, and everyone else for joining us today. Leanne and I are very excited for this opportunity to present 2 new topics to the U.S. National Climate Assessment process. So these chapters, it's the first time they've ever appeared in a National Climate Assessment of the United States. I will first be focusing on Chapter 16, Climate Effects on U.S. International Interests. But before we get going, I really need to acknowledge this incredible team that I was able to work with. This was no small task We were asked to produce a new chapter on a very broad and complicated issue, and then try to keep it to around 6 pages. And I know we're quite proud for what we produced. In particular, I would like to acknowledge, I'm getting used to changing the slides, here we go. I'd like to acknowledge our chapter lead, Joel Smith. Other authors represented 4 different U.S. agencies, NOAA, Department of Defense, USAID, and the Department of State, as well as academic experts on this topic. This was a tremendously rewarding experience for each of us to participate in and learn from each other. So thank you. I see many of you on this call as well, so I'm glad that you could join us. Sorry, just trying to figure out. There we go. Okay. Moving on to the topic of today's webinar. So some of you may be asking, why was an international chapter added to a nationally focused scientific assessment? So let me start with the fact that global impacts of climate are already having important implications for societies and ecosystems around the world and are projected to continue to do so in the future. And these impacts have been addressed in several global scientific assessment reports, such as the Intergovernmental Panel on Climate Change, and are also illustrated in a growing field of nationally focused climate assessments throughout the world. So as shown in this top figure and currently described in more detail in Appendix 4 of this report. Now, the integration of the international context in a U.S. climate assessment was identified as a key gap in earlier versions of the NCA, as well as during public input during the NCA4 scoping process. But again, why is it necessary to include an international context? Well, because weather and climate cross and ignore our geopolitical borders. Resources, people, and goods also cross our borders, which further increases the connections between the U.S. and the global economy and community. And a national climate assessment should reflect this connectivity. In fact, international land and water borders are found in 9 of the 10 NCA regions in this report, as shown in the bottom figure. So with this in mind, the international context of this NCA4 report focuses specifically on U.S. interests that can be affected by climate-related impacts occurring outside of U.S. borders. And this includes climate variability, climate extremes, long-term changes. And today I will provide a brief overview of climate-related risk in 4 areas of U.S. interest, which are separated by sections in the chapter. And additionally, I will draw some examples from throughout the report of actions being taken to manage these risks. And these 4 areas are 1, economics and trade, 2, international development and humanitarian assistance, 3, national security, and 4, transboundary resources. So let's start with our first one, which is economics and trade. For each of these sections, I have pulled and identified the key message from the report in the shaded boxes. Now, this key message states that the impacts of climate outside the United States are affecting and are virtually certain to increasingly affect U.S. trade and economy. Now, this will be particularly felt in 2 areas. The first is that the U.S. economy and trade is impacted through global changes in imports and export prices. Now, what does this mean? Climate change is expected to lead to large-scale shifts in the availability and prices of a wide array of agricultural, energy, and other goods, with corresponding impacts on the U.S. economy. These impacts occur on a wide range of timescales, ranging from months to multiple decades. So, for example, the prices of agriculture mining commodities are affected by both year-to-year and decadal climate variations in the availability of irrigation water for agriculture or hydroelectric power. So those U.S. communities that have a high dependency on global trade, in particular, such as Hawaii and U.S.-affiliated Pacific Islands, are even more vulnerable to the impacts of climate change on the global economy. Now, moving to a second mechanism is that climate can directly impact overseas operations and supply chains that U.S. businesses rely upon. So in our global economy, this can include services, infrastructure, and resources in other countries that are U.S. or foreign owned. And let me provide an example shown in the diagram on the right. Western Digital is a U.S.-based company that produces 60% of its hard drives in Thailand. A 2011 flooding event led to nearly $200 million in losses and a significant reduction in hard drive shipments. So this shortage led to a temporary doubling of global hard drive prices that affected other U.S.-based businesses, including Apple, HP, and Dell. The same flooding event in Thailand led to a temporary halt in the production of vehicles in Thailand, by a U.S.-based Ford company. And so this just illustrates how an extreme event on another continent can affect U.S. business interests. Now, what are examples of actions that U.S. businesses are taking to address these risks? Well, they are starting to be recognized and reported and acted upon by businesses. The Financial Stability Board's Task Force on Climate-Related Financial Disclosures has encouraged businesses to report these risks, with hundreds of businesses currently enlisted as partners in this effort. And some U.S.-led businesses have already started to reduce their climate risk abroad. One way they are doing this is through partnerships with environmental groups. For example, Starbucks and Conservation International have partnered to strengthen the capacity of coffee farmers and supply chains to manage climate risks, and Coca-Cola and the World Wildlife Fund are working together to protect foreign watersheds that Coca-Cola uses for water supply. We do know that few studies exist that quantify the impact of climate change on U.S. corporations, and this is certainly an area requiring additional attention. The next section is international development and humanitarian assistance. Developing countries are highly vulnerable to climate extremes, such as tropical cyclones and drought. This is because it can dramatically slow or even reverse social and economic progress in those countries and increase the need for disaster response and recovery assistance. For example, Hurricane Mitch in 1998, the bottom left photo, devastated Honduras and Nicaragua, killing thousands of people and causing widespread damage to property and infrastructure. USAID and the U.S. Department of Defense jointly responded with an immediate relief effort. In addition, USAID has also reoriented many of its programs in this region to focus on longer-term recovery and to address how this disaster set back development goals. In another example, the U.S. military conducted humanitarian and disaster relief efforts in the aftermath of Typhoon Haiyan in the Philippines in 2013. Examples of this relief effort is seen in the bottom right photo. So climate change is likely to increase the demand for U.S. humanitarian assistance of this kind, given the expected increase in the severity of extreme events like tropical cyclones and droughts. Now, what actions is the U.S. taking to address this risk? The U.S. government systematically identifies climate risks and seeks to reduce the vulnerability of its international development investments. For example, the Millennium Challenge Corporation, or MCC, for those not aware, is a small but innovative and independent U.S. foreign aid agency that is addressing global poverty. The MCC amended its environmental guidelines in 2012 to formally adopt standards, which includes provisions on climate risk management. USAID also has climate risk management guidelines. In addition, there are many, many ways that the U.S. is working with the international community to better predict, anticipate, plan, and respond to what will likely be more extreme events. And there are several examples highlighted in Chapter 16. Now, one area I would like to highlight is related to the agriculture sector, as many developing countries depend heavily on agriculture as a major source of jobs and a large percentage of their gross domestic product. So the U.S. is working at several levels to help countries anticipate drought and to provide farmers with tools to manage risk to their crops and finances. One example, the United States is investing in early warning systems in developing countries, such as the Famine Early Warning Systems Network, also known as FuseNet, a joint effort by multiple U.S. agencies created after a devastating drought in Ethiopia in 1984. And currently, FuseNet works with governments and international partners in 34 countries to develop scenarios of food security 6 to 12 months in advance. This results in a figure such as the one shown here, depicting projections of peak populations in need of emergency food assistance. This one is from 2018. And this allows USAID and others to mobilize emergency aid programs before the drought and food crisis materializes. Now, the next section is on climate and national security, where we discuss how climate change and climate extremes increase risks to national security in two ways we focus on. One is direct impacts on U.S. military infrastructure, and two, by affecting factors including food and water availability that can exacerbate conflict outside U.S. borders. I would like to focus first on the direct impacts on U.S. military infrastructure. This was mentioned in multiple chapters within the NCA4 report. Now, climate change is already affecting U.S. Department of Defense assets by, among other impacts, damaging roads, runways, and waterfront infrastructure. One example is the Naval Station located at low-lying Norfolk, Virginia, shown in the picture to the left, Both the lower and upper bound of sea level scenarios predict sea level rise in this particular location. Now, what actions is the U.S. taking to address this risk related to U.S. military infrastructure? The Department of Defense is working to both fully understand these threats and incorporate projected climate changes into long-term planning to reduce risks and minimize impacts. And here are two examples. One, to identify DoD installations with vulnerabilities to climate-related impacts, a preliminary screening level vulnerability assessment survey of DoD sites worldwide was conducted in 2015. So shown in the bottom right photo, the survey responses provided a preliminary qualitative picture of DoD assets that are currently affected by severe weather events, as well as an indication of assets that may be affected by sea level rise in the future. Another example, DoD has performed a comprehensive scenario-driven examination of climate risks from sea level rise to all of its coastal military sites, including atolls in the Pacific Ocean. Additional details can be found in Chapter 8 on coastal effects. And then in the Arctic, the U.S. Coast Guard and Navy are pursuing strategies to respond to the changing geopolitical significance resulting from the projected absence of summer sea ice in the next few decades, talked about in Chapter 2, Our Changing Climate. Now, the second aspect of climate and national security focuses on the relationship between climate-related stresses on societies and conflict. Now, direct linkages between climate-related stress and conflict are unclear. However, climate variability has been shown to affect conflict through intermediate processes, including resource competition, commodity price shocks, and food insecurity. The potential for conflict increases when there is a history of civil violence, conflict elsewhere in the region, low GDP or economic growth, economic shocks, weak governance, and lack of access to basic needs. For example, severe droughts around the world in 2010 contributed to a doubling of global wheat prices in 2011 and a tripling of bread prices in Egypt. And above is a photo showing the serious damage to Russia's wheat crops by drought and wildfires. So this and other factors, including national trade policy and poverty, contributed to the civil unrest that ultimately resulted in the 2011 Egyptian revolution. So while the 2010 droughts were not the sole cause of the revolution, they contributed to destabilization of an already unstable region. Now let's transition closer to our borders for our fourth and final section on transboundary resources. Now, as stated before, 9 of the 10 NCA4 regions and the regional chapters include international land or maritime borders. The shared borders of the United States are extensive. 17 states share rivers or lakes with Canada and Mexico. Hawaii and other island areas, including the U.S. Caribbean, the U.S. affiliated Pacific Islands, and the Arctic region, also share maritime borders with 21 countries. Now, climate variability and change, as well as extreme events across these shared borders, can have direct and indirect impacts on those living inside the United States. So shown on the slide are a few examples. On the left, long-term drought conditions often span across the border, as seen in this North American Drought Monitor map from 2011, where the darker colors indicate the severity of the drought. In the top right, transport of smoke from wildfires across the Canadian borders can lead to air quality and health concerns in the United States. This figure shows smoke from Canada wildfires in 2017 moving south to the U.S. Dust storms and wildfires have also crossed the border from Mexico to the U.S. due to increased temperatures coupled with decreased precipitation in northern Mexico. And not shown here, we are already seeing changes in the movement of fish species due to changes in water temperature, which is further described in Chapter 9 on oceans. So, for example, our chapter highlighted the migration of Pacific hake, an economically important fish species that migrated northward from the United States to Canadian waters due to warmer ocean temperatures during the 2015 El Nino. And additionally, climate impacts are likely to exacerbate cross-border issues related to many other issues, including human health. So, for example, the past 2 decades have seen the introduction or reintroduction into the United States of several vector-borne diseases, including West Nile virus, dengue, and most recently Zika. This is described in more detail in Chapter 14 on health. The recent Zika outbreak began in South America and spread to areas with mosquitoes capable of transmitting the virus, including the Puerto Rico, the U.S. Virgin Islands, Florida, and Texas. Now, while climate is only one factor influencing the spread of these diseases, it is believed that warmer conditions provided the opportunity for mosquitoes, as shown in the bottom right photo, and other disease-carrying pests to increase their geographic range northward. And these changes, in combination with international travel patterns, could facilitate establishment of these diseases, especially in the southern United States and the U.S. Caribbean territories. Disease outbreaks occurring in other countries can also impact U.S. populations and military personnel living abroad. Now, I'd like to spend a few minutes talking about, or 1 minute, talking about one very important transboundary resource, water. Shared water resources along U.S. land and maritime borders provide direct economic and social benefits to Americans and are vulnerable to impacts from a changing climate. So this includes, as stated on the slide, irrigation, drinking water supplies, power generation, flood risk management. Now, shared water resources such as rivers and lakes are particularly sensitive to changes in precipitation. In the U.S.-Mexico drylands region, large areas are projected to become drier, as described in Chapter 23 in the Southern Great Plains, and this is expected to present increasing demands for water resources on top of existing stressors associated with population growth. Now, along the U.S.-Canada border, changing weather patterns along rivers such as the Columbia River, which originates in Canada, affect the amount of water available for agriculture and energy sectors. Complex water laws govern allocation between the U.S. and both Canada and Mexico. This is further complicated because water supplies change with year-to-year variability in precipitation and water use, among other factors. Now, Chapter 3 of the NCA4 report, which focused on water, highlighted the importance of these binational agreements, and I put a quote here that states continued collaboration on transboundary watershed coordination agreements are among the actions that could facilitate more sustainable binational water management practices. Now, the good news is that this is already happening. The management processes of shared water resources is increasingly incorporating climate information into decision-making processes. Several agreements between countries have recently been restructured to consider changing weather patterns and related management challenges to include climate risk and adaptive management into their near and long-term strategies. So let me provide a few quick examples that are illustrated throughout the report. Along the U.S.-Canada border, researchers are incorporating climate information into computer models of stream flow and reservoirs in the Columbia River Basin, shown in the first photo, to help decision makers understand the long-term potential impacts of flood risk management, hydropower generation, and water availability. Now, along the Mexican border, the International Boundary and Water Commission, which implements water treaties between the U.S. and Mexico, is exploring an array of adaptive water management strategies, additionally described in Chapter 25 on the Southwest. For example, the Colorado River has more than 30 electrical power plants along its run, as well as dozens of dams and reservoirs. Local water utilities, the governments of 7 U.S. states, and the federal governments of the U.S. and Mexico have voluntarily developed and implemented solutions to minimize the possibility of water shortages for cities, farms, and ecosystems. And this includes the design of flexible surface water and groundwater storage facilities, coupled with government mechanisms that continuously account for changing climate conditions and water demand. In addition to government management of transboundary resources, public-private partnerships are increasingly helping to manage climate risk associated with these resources. One example we highlight in the Rio Grande Basin, which is highly sensitive to variations and changes in the climate, are bilateral public-private partnerships that have been implementing collaborative science, restoration, and monitoring actions to restore the river, with climate adaptation as one of the objectives. And this is to support the valley's extensive agricultural productivity. So these examples of proactive and collaborative binational water management strategies allow for effective flood control, mitigation of drought impacts, and maximization of water quality, among other benefits, and are essential to supporting the agricultural, industrial, and community infrastructure in the U.S. Now, the U.S. Caribbean and Hawaii and the Pacific Islands are also very engaged with international partners to build adaptive capacity and reduce risk associated with climate change uncertainty at the regional level. Now, this figure from Chapter 20 on the U.S. Caribbean shows some of the organizations working on climate risk assessment and management in the Caribbean. These joint regional efforts to address climate challenges include the implementation of adaptation measures that reduce natural, social, and economic vulnerabilities, as well as actions to reduce greenhouse gas emissions. Now, scaling up to the global level, cooperation with international science efforts significantly enhances our understanding of the impacts of climate variability and change here in the United States. Why? Because understanding global scale phenomena that impacts the U.S. So this kind of phenomena that was described in the first volume of NCA4, Climate Science Special Report, and in the IPCC reports, this type of understanding exceeds the capacities and the capabilities of any one country alone. Additionally, cooperation with other international and national scientific organizations enables the United States to better observe, understand, assess, and manage the impacts of climate processes on U.S. interests within and outside of our national borders. Now, I highlighted here a few examples of benefits to the U.S. of international scientific cooperation. For example, access to observations, data, and knowledge that can shed light on how global processes affect the U.S. Opportunities to leverage funding and equipment in the development and maintenance of climate observing systems, spreading the costs among countries that participate, and a few more examples here related to joint research and sharing lessons from other countries that can help us in the United States with risk management and adaptation. Okay, in my last slide, I would like to leave you with two high-level takeaways from this assessment. And there are no figures or images, so you're just going to have to pay attention. But these are really important, and we highlight these at the end of the chapter. The first one is the impacts of changing weather and climate patterns beyond the U.S. international borders affect those living in the United States and U.S. interests abroad. We have very high confidence in the statement. But despite this level of confidence, the mechanisms by which climate impacts beyond American borders affect U.S. interests are not uniformly well understood. Some of this uncertainty arises because these impacts are part of complex systems. Now, what do I mean by complex systems? Recall the damaging impact that severe droughts had on global wheat production that I mentioned earlier in 2010-11. A corresponding reduction in wheat production, in combination with high demand, low stocks, trade policies, and other factors, contributed to the spike in global wheat prices. Where impacts increase global market prices, U.S. purchasers and consumers tend to be harmed through increasing costs of flour and bread, whereas the U.S. producers tend to benefit with higher export prices. And another example of complexity, recall the connections between climate and national security, which are very complex because national security can be affected through intermediate processes such as resource competition. So such processes are challenging to model and forecast because they can be affected by such difficult to predict factors such as policy decisions, human behavior, and climate surprises. Now, while the four topics I presented were addressed separately, they also affect each other, again, in complex ways. For example, climate-related disasters in developing countries not only have significant local and regional socioeconomic impacts, but they can also set back U.S. development investments, increase the need for U.S. humanitarian assistance, and affect U.S. trade and national security. So these are just a few examples. I would also note that this complexity not only generates challenges, but also potential opportunities. We highlighted a few of these in the chapter. There are instances, for example, where scarcity has led to increased cooperation amongst countries rather than conflict. Also, potential summertime availability of transarctic shipping may lead to new transportation opportunities, although the infrastructure to support this transportation pathway has not been developed. Now, the second takeaway message is that while there are efforts underway to adapt the climate and manage risk to these U.S. international interests, as described today and in the report, our understanding about the effectiveness of these particular adaptations and their potential to offset adverse impacts is really quite limited. So as such, it is highly unlikely that the measures implemented so far will fully avoid or offset the adverse impacts of a changing climate on U.S. international interests. So I would like to leave you in summary with two emerging areas that are currently not well understood and really requires additional attention and research. One, the mechanisms by which climate impacts beyond American borders can affect U.S. interests. And two, the effectiveness of actions to either offset adverse impacts or take advantage of positive impacts. Now, we anticipate and hope that NCA4 will have more information that will help us better understand the complex interactions described in this chapter, which I think is a very good segue to the next presentation by Leon, which I'm very much looking forward to. But before we switch over, let me thank you again for your time, and I look forward to any questions that you may have.
Okay, thank you so much, Meredith. I think we're going to hold questions I think we'll hold questions because it's 12:30, but you can go ahead and type them into the chat box. Meanwhile, I'm going to bring Leon's slide up, and Leon, if you could unmute yourself, that would be great.
All right, can you hear me?
Yes, you sound great.
Okay, good.
And your slides are coming up. Thank you, Meredith.
Okay, great. Okay, great. So, yeah, this is actually extremely complementary to Meredith's to the last presentation. So what we were asked to do, and again with a new, semi-new chapter, was to think about how different sectors interact with one another and how those interactions may end up being far more complex than we might have anticipated, and what that means for how we think about climate assessment. So we know these things are related. We know, and I'll go into this in just a moment, we know that sectors interact with one another. We know that a range of different forces impact those sectors. But we don't exactly know, or do we know, I guess is the question, how much they interact with one another. So before going forward, let's make sure I can move to the next slide. Before jumping in, I just wanted to say also thanks to the team, which is listed later in the slides, and also a special thanks to Tony Janatus, who's no longer with us, but has had an enormous influence on the topics that the National Climate Assessment was actually the first person I called when I was asked to do this chapter. So we will definitely. With that, just jump in. So there's just to sort of give an introduction to how to think about this. We all know the first point here, which is that a wide range of different climate-related risks, heat waves, floods, droughts, and so forth, can impact the systems that we care about, natural systems, built systems, social systems, and so forth. What's important for this chapter is the idea that they don't only affect those systems individually, but those systems affect one another. And that means that if we have an effect on one system, we can start to see effects on other systems. So for example, effects on water systems can have important impacts for agriculture and important impacts for electricity, and so on and so forth. In addition, what's really important to note is that climate-related impacts do not live in isolation, do not exist in isolation. They actually are interacting with a wide range of other stressors, many of which end up being either more powerful or end up actually increasing the effect of the non-climate stressors: population growth, economic forces, technological changes, new technologies that are used, infrastructure investments, and so forth. And so the basic point of this chapter is that assessing the risks associated with climate requires understanding these various dynamics. And just to step back, to me there's kind of two ways that this plays out. One is a relatively straightforward one, which is that we want to just articulate in this chapter and make clear that you really need to think about these interactions between multiple stressors and between multiple systems. And if we don't do that, we're absolutely missing something and may not be on top of what the full impacts are from climate change. But the second one, which I think we have sort of scratched the surface of, but really have not nailed, is this notion of complexity that Meredith brought up in the last talk. And there's a great deal of literature that goes back in a wide range of different areas of research, from ecology and so to others, that looks at complex mathematics, ecology, and so on and so forth, that looks at complex systems. And some of the key points there are that they have unpredictable behaviors. And that also is an important part of this chapter, not to just only say that these systems interact with one another, but also there's a lot of challenges in understanding what the outcomes may be from those interactions, and a lot of complexity. And then I thought, and I really think for what it's worth, that the international chapter was a very good illustration of both of those themes, both these interactions across sectors and space, but also the notion of complexity, particularly when you're dealing with the ways that social systems work together. We originally had some examples from the international chapter, but then just left it to the international chapter. So let me just start to work through. So we have 4 key messages, and they're pretty high level. Again, we don't have a lot of space here, but they're meant to make the point, in some sense, a call for continued action to try and understand these issues. So the first one is simply making the point that there are interactions in the sectors. So the sectors and systems exposed to climate interact and depend on one another, as well as other sectors that are not actually all that exposed directly to climate. These systems are not only exposed to climate, but they're also exposed to these other factors that I discussed earlier that can really drive the way that systems behave. And then they deal with, they lead to a range of complex behaviors that are difficult to understand and predict. And so the bottom line here is this last sentence, which is it's not really fully possible to understand the implications of climate change on the U.S. without considering the interactions among sectors and their consequences. And this schematic here is an illustration of the basic concepts that we were trying to get across. So if you think about how to address climate impacts, we might just start with one of these sectors. So let's just say energy. There's a circle on the top that says energy. And energy system itself is already extremely complex, right? So there's wind power can be affected by climate, solar power, hydropower, demands for electricity, which can change with time and not only get larger in general, but you can have heat waves, which produce periods of very high demand. So the energy sector is already very complex as it is. But the energy sector actually interacts with a wide range of other sectors. It depends on water for hydropower and for cooling. It actually is used to convey water. The energy sector, in some future scenarios, may actually depend on bioenergy. It also produces electricity for use in agricultural systems. The energy system is part of the transportation system, and actually, as we're moving to a more electrified transportation system, the electricity system is highly connected. So you can see that all these systems are highly connected with one another, and impacts in any one of them may affect the others. But at the same time, as you look on the outside, there's a wide range of different influences that might impinge on these systems, and that ranges from a wide range of non-climate-related influences, which I've already sort of articulated, and climate-related influences. And again, a really important part of this chapter was to articulate that you don't want to just think about the climate influences. The way that the non-climate influences interact with the system is quite critical. So now let's just jump to a couple of examples. So just to start, if we think about Hurricane Harvey, which was relatively recent at the time we did this, there's a couple of things that are important to note. So Hurricane Harvey, first, it knocked out power to about 300,000 customers in Texas. And that had cascading effects on a range of infrastructure, which could include water, sanitation. There was actually a wide range of pollutants running through the water, hospitals, and so forth, as well as refineries. So that's number one. It's first that this particular activity knocked out a wide range of different infrastructure, and so it wasn't simply the effects of flooding directly, but the effects on the infrastructure. A second, a lot of the point I would make is that a lot of those systems interact with one another. So the electricity system, the flooding knocked out transportation systems, which were very important for conveying people to hospitals. Hospitals are often lost electricity, and so on and so forth. But third, I think, is really important to get at this point that I mentioned earlier about non-climate influences. A lot of the issues that emerged from Harvey actually had, in some sense, but the resilience of the system to Harvey was influenced heavily by land management practices over the last number of years that have reduced the wetlands that might actually have been able to reduce the impacts of Harvey itself. And so this would be sort of a classic example of an extreme event cascading failures throughout the system, but also one in which human decisions about the structure of the social or physical system had a big effect or had an influence on what actually happened. A second example, which is very much on people's minds, particularly in the Southwest, is energy, water, land interactions. So I think we all know, but I'll just go through and state it again, that energy, water, and land systems are all interconnected. And this was actually, I think, a topic in the last NCA. But water is used to cool power plants. It's used for hydroelectric power. Energy is used to move water. Water is critical for agriculture, which is one of the primary means. Anyway, yes, it's critical for agriculture. So the interactions between these have to be very well understood and actually managed around to be able to successfully handle climate change as well as these other driving forces. So just to give an example, the interactions between these three sectors and climate change in California give a really good example that illustrates the need to understand these complex systems. So hydropower generation in California supplies an average of 15% of the state's total electricity consumption. Well, at the same time, the state's thermal electric power plants rely on water for cooling. Meanwhile, the state water project is California's single largest electricity consumer, demanding an average of 2 to 3% of total generation. That's for pumping and conveyance of water. The state's agricultural sector demands approximately 40% of the average available fresh water and uses substantial amounts of seasonal peak load electricity to pump groundwater, particularly during the droughts. So as we think about these going forward, California is a really good test bed for thinking about some of the dynamics that might occur. So for example, taking California's recent droughts as an example, when surface water supplies were curtailed from 2002 to 2016, the result was increased well pumping to meet agricultural demands, which led to a loss of approximately 5 cubic miles of groundwater, or about the size of Lake Powell. Increasing well depths and then loss of hydropower production influence farmers' decisions about both capital investments in pumping and transitions to higher profit tree and vine crops that cannot be fallowed. So actually, if you drive through the Central Valley in California, what you see is even during a very intense drought, there was inefficient use of water for crops that are not really built for a drought. And in addition, the choices that are made about utilizing that groundwater will have long-term effects on the ability to backstop future droughts. So as we continue to use that water, now our ability to basically manage crops, manage the energy system, manage urban use of water will be heavily influenced by those decisions made today. And that's the kind of thing that I guess we in some sense can predict today, or we can predict today. But those are the sorts of dynamics that were really important for us to highlight in this chapter. Going to the next example, we included a number of examples just to get at the notion of complexity, not necessarily always in the context of climate. So one example that was pretty interesting, which actually Tony had brought to the group, was the notion of what happened to wolves and beavers and the ecosystem in Yellowstone and the importance of human decisions in driving that system. So what happened was that humans decided they didn't really want the wolves around, particularly in the context of livestock. That increased elk herds. Elk herds then ate the willow trees by the banks of the rivers and then in streams. And that cut down on the beaver population and changed the entire ecosystem. Now, over time, the wolves have been reintroduced, and that's actually brought down the elk herds and changed some of the ecosystems, but in many cases, indeed, those systems have not really returned to their original state. And this was not at all anticipated at the time. Simply, the issue at the time was simply trying to reduce the number of wolves to deal with livestock herds. But there were unanticipated effects, and that's the kind of thing that we're trying to think about will be important in the context of climate. And what's kind of hard about it is they were unanticipated. And so as we look back, we can't talk necessarily always about the unanticipated effects because now we can look back in retrospect. But as we think forward, do we have the capability to anticipate these sorts of dynamics moving forward? So let me jump to a couple more messages, and then I can wrap up relatively soon. So the first point had been just that these systems are all interacting. We need to understand those interactions, and if we don't, we'll end up being in a spot where we actually miss what's very important. The second is a little more proactive point that, the second point is then a risk assessment needs to really assess all of these interactions. But one of the things that I'll get to at the end, but I think is really important, is that our predictive capabilities to understand all of these interactions are pretty challenging. And so as we think about risk assessment in the context of these multi-sector dynamics, it's important to be thinking about methodologies that are not simply quantitative modeling analyses, but that incorporate a wide range of different evidence and explore a wide range of different possible outcomes. In some sense, we're living under a great deal of deep uncertainty, and so we need to be assessing these risks in a way that is open to that uncertainty, even if we don't necessarily have the modeling tools always, or the analytical tools always, to be able to predict the future. Then the message number 3 is more proactive, which is just saying that joint management of these systems can have a very important impact on the way that on their resilience. So for example, just to give the classic example, the management of energy, water, and land systems is a joint management of energy, water, and land systems is quite critical for ensuring that those systems are going to be amenable to or resilient to droughts and other climate-related activities. And I think there is increasing effort to do just that. But it is also true that in many cases those systems are managed semi-independently. But management of moving towards an approach that is more integrated is critical for managing the risks in these complex situations. So a couple more just examples, and I'll come to the end. So in the context of fire, we looked at that a little bit. So multiple stressors do impact U.S. forest systems. In the western U.S., particularly in Colorado, California, wildfires have become more frequent and larger, as I think everyone is quite aware of, and this trend is expected to continue. But at the same time, social system dynamics have had a very important influence on what's going on. For example, as humans have moved and expanded the wildland-urban interface, increased fire suppression practices have led to changes in vegetation structure. Without natural fires, vegetation has become denser, resulting in significantly larger and more damaging wildfires. And meanwhile, the interaction of pests with wildfire includes feedbacks that sometimes nonlinear. So for example, warmer winters have allowed pests such as bark beetle to reach higher elevations and cause significant tree mortality. All of these are interacting together. And the notion of humans interacting more at the interface with wildlands and then the way that we manage those can have cascading impacts back and forth. And then the last example I'll give is the Northeast blackout, which is sort of a climate-related example. But for those who are not aware, in 2003, there was a blackout that occurred because of sagging power lines. And once those power lines sagged, and I guess at one point in the system, sagged and had a failure, it then actually cascaded throughout the entire Northeast with an estimated 15 million people out of power. Now, this isn't necessarily talking about a flood or a hurricane or a drought, but it is also noting that these very complex systems that support our economy are often susceptible to these sorts of catastrophic failures, and often those are unpredictable. So the final point I'll make is just that as we looked across this chapter and we started to say, okay, well, what is how can we think about some of these sectoral interactions and some of this complexity? What we kind of found was that we end up understanding relatively clearly that they do exist. And again, I think that the international chapter is a perfect example of this. We do understand that there are these interactions. There's the energy, water, land interactions, the way that we interact with forest systems and interacts with the way fires interact with those, and those can interact with the way that we plan our communities, how close they are to fire systems, and so forth. Floods can influence a wide range of different infrastructure, and so on and so forth. So we know those are there, and we tried to highlight some of those. But at the same time, I think we found really that there's two areas where the literature is not all that supportive yet, and that there's really a need to think more deeply, or at least plan around. And one of those is, again, this notion of unpredictable systems. What are the kinds of outcomes that we can't predict today? Well, we can't predict them. So it's very hard. But this notion of complex system interactions, emergent behavior, very unpredictable, deep uncertainty is something that we felt was very hard to wrap our minds around. And then there was another sense that related to this, the literature is really just emerging in this area, and one of the challenges is that, again, going back to that last point, the complexity of these systems makes standard analytical tools, or challenges standard analytical tools. And so there's a real question of what kinds of models and tools will really be most useful from a predictive perspective to handle these issues. And there's certainly a lot of work now going on in the context of energy, water, land interactions. There's certainly work looking on international agricultural systems, for example, and so forth. But there's a lot more that needs to be done if we're really going to be able to identify some of these what are now unknown unknowns, to use that language. So with that, I will stop and leave it open to questions for either of us going forward.
Great. Thanks so much, Leon. Great presentation. Folks online, if you have any questions, go ahead and type them into the chat box. Anybody in the room? Questions? These are questions for Leon or Meredith.
Well, I would just like, this is Katie, and I'd just like to say, while we wait to see if we have any questions, I would just really like to thank both of you today. I think these were really excellent presentations, and these are topics that can be really complicated and nuanced, and I think the audience would agree that you've done a great job of explaining them very clearly and demonstrating as well how they relate to each other. So thank you very much. And also, I would encourage all of the listeners on here to check out the NCA4 website if you haven't already. I've included links to both of these chapters in the chat box, but you can also, so you can read the full chapter, but you can also download materials, including the overviews, the chapter executive summaries, many of the figures that were shared today by our presenters, and even chapter-specific PowerPoint files. And those are all at nca2018.globalchange.gov/downloads. And we'll see if anybody, looks like we've got some folks typing.
Leon, this is Tracy, Leon and Meredith. I have a question for you. So do you know of any computer models right now that are dealing with, say, more of the marine side of things, like the effects you have, like heavy rains, heavier than normal rains, how that affects HABs, harmful algal blooms, and how that affects fisheries?
Sorry, you broke up a little bit. That was for me? Is that correct?
Either one.
I would say yes. They do exist. And I'm happy to get, if that's a specific example, then I'd be happy to get that. Integrated model is just the way of the future, but it's only as good as the data that we have. I would imagine that we're going to see a big change between NCA4 and NCA5 on this topic in terms of these interdisciplinary, intertopic, interconnected models that are trying to link the biological, the physical, the social elements. Really complicated stuff, but I think we're moving in that direction as a research community.
Yeah, I mean, yeah, I'll leave it at that.
And then David Reed-Miller mentions, apologies if I missed this as I had to join late, but can the presenters talk a bit about how the author teams narrowed the scope of their chapters? And what are some of the most pressing research questions to emerge from their assessment? Meredith, do you want to go first, and then Leon, you can follow?
Sure. With a topic as broad as international impacts on U.S. interests, we really started with just laying out the landscape of all the different topics that, essentially a big brainstorming session. And then starting to move forward to a little bit of the literature background to see where we have scientific information that we can draw from and what topics really stood out. So the 4 areas that I focused on in my presentation just kind of floated up to the top, and of course we couldn't cover everything because we were limited in terms of page length, etc. And really the way I see this international chapter, it was really just planting seeds. Each one of these topics could in fact be its own chapter, could be its own scientific assessment. There are assessments out there emerging on different areas such as transboundary on water resources and national security, etc. So hopefully that answers your question, David. We just ended up having to narrow the scope largely based on what was available as well as what we thought would be compelling for the audience. Oh, and some of the most pressing research questions, I did leave that at the end in terms of my key takeaway questions. It's just these complex mechanisms on how climate impacts beyond American borders can affect U.S. interests. We just need more research. There's not a lot. There's very little in terms of how U.S. businesses are impacted by what happens abroad. I was a little surprised at how little was actually out there. And then in addition, of course, looking at the effectiveness of these early actions that are taking place in terms of managing risk and adaptation. Many of these actions haven't been around for a long time, so we haven't had a full opportunity to explore if they've been effective or not. So again, I think in the next few years we'll be farther along in that area as well.
Okay. And Leon, do you have anything to add today?
Yeah, so I can say a little bit for ours. Also, we were also, I think, in a very comparable space to Meredith, which was the space of trying to articulate that this is important and that there are some key themes around the topic that we need to keep our eye on. And so in some sense, we didn't actually narrow that much. We wanted to do 2 things. We wanted to show that there were these interactions both across sectors but also between climate and non-climate stressors, and to make that very clear so you don't get caught in the notion that we just want to think about today's world and the climate stressors on today's world, but we want to think about the joint evolution. And the second thing we wanted to do was raise this notion of complexity and the unpredictability of these systems, which I think we only really, in some ways, barely scratched the surface of. And I think as we look forward, to me there's a number of areas that are just really critical. One is there needs to be, we need better tools to be able to look at some of these interactions, or at least we need to be doing more research specifically on these interactions. That's number one. But I would also say, as I said earlier, that these are so complex that I think we're going to have to be able to assess issues without having gotten everything right in our tools. And sometimes just by using a range of other methods besides quantitative methods. I come from a modeling background, and obviously folks who let you do quantitative modeling think that's the way to do it. I do in some sense, but I think these are so complex we can't always do that. And I also think we have to watch out for just getting under the lamppost. There's, for example, a lot of work now on energy, water, land interactions, in many ways because those are amongst the easiest to model. But there's a wide range of very complicated changes, many of them having to do with social systems, national security issues, geopolitical dynamics, societal changes, that I don't think we have to have that we don't have a good handle on and aren't going to have a great handle on anytime soon. And so we need methods for moving ahead when we can't really get our minds fully wrapped around this. That's something that came out pretty strongly for us, but this stuff is just so complex. You're not going to build a model to be able to predict all of it, and we need to be able to plan around that uncertainty.
Right. Well, thank you. And then Steph Miller asks, are you measuring how public or private decision makers are utilizing the NCA? David Reed Miller replies, Steph, to a degree we are doing that through informal solicitation of use cases, which we are always collecting if you have any, and also web analytics and an exploration of a possible external evaluation of how/why the NCA is or is not being used. And then Katie reminds us that the recording and the PDF will be available at the website. And Katie, you want to mention next week's seminar?
Sure. So actually, I hope you'll join us in 2 weeks for the final seminar in our series. That is, I believe, September 3rd. It's a Tuesday at noon, as usual. And that final webinar is going to be Actions to Reduce Risks, Findings from the Fourth National Climate Assessment, and that is featuring Dr. Roger Pulwarty from NOAA and Jeremy Martinich from the EPA. So I hope that you will join us then.
Yeah. Okay, well, thank you so much, Meredith and Leon. Terrific presentations. And folks online, we hope to see you on September 3rd. Any last words? Leon, Meredith, Katie?
So just thanks for the opportunity.
Yep. Same here. Thank you so much for joining us today.
Thanks.
Thank you.
Bye-bye.
Thanks. Bye-bye.